This molecule is organic. It's also a gas that would suffocate you in a closed room. And this? Perfectly natural, dug straight out of the earth, and not organic at all. Because organic was never about natural or healthy or alive. It's about one thing: carbon. So why carbon? Carbon has 4 electrons to share, so it makes 4 bonds, 4 hands. Hydrogen makes 1, oxygen 2, nitrogen 3. Carbon makes 4, and that 4th bond changes everything. Spend 2 of them continuing a chain, and you've still got 2 spare. To branch, to ring, to hang something off the side. It isn't that carbon's heavy or reactive, it's just that number, 4. Watch what 4 buys. Carbon bonds to carbon, over and over. A chain, any length you like. Kick a spare bond out sideways, a branch. Curl the chain around till it closes, a ring. Chain, branch, ring. Every single molecule in the next 4 topics is just some mix of these 3. That skeleton is what organic means. Even carbon dioxide misses the cut. One lonely carbon is not a skeleton. Now the mistake that costs the most marks. Here are 2 molecules with the exact same carbon skeleton. Bolt a hydroxyl onto one. That's ethanol, drinking alcohol. Bolt a carboxyl onto the other. That's vinegar. Same frame, completely different molecule. The skeleton just holds the shape. The group on the end decides the chemistry. Those end clusters are functional groups, and there are only a handful worth knowing. Carboxyl gives a proton away. That's an acid. Amino grabs one. That's a base. Memorize that pair together. Because an amino acid carries both, which is exactly why it can swing either way. Pull back. Just 6 elements builds almost everything you are. Schnapps. About 97% of your math. But carbon, hydrogen, and oxygen show up in every class, so finding them tells you nothing. The useful 3 are nitrogen, phosphorus, and sulfur, the clue elements. They tell you what you're actually holding. Nitrogen rides in on amino groups and bases. Phosphorus builds DNA, ATP, and membranes. Sulfur staples proteins into shape. So here's a molecule as nothing but a list. Nitrogen and sulfur, no phosphorus. Ignore the core, read the clues. Nitrogen, sulfur, an amino and carboxyl pair. That's an amino acid. It's a protein. Learn the 4 fingerprints once, and you can name any macromolecule on site. Last trap, and it's a quiet one. Here's you, by mass. Oxygen, carbon, hydrogen, then it falls off a cliff. Iron is 0.006 of 1%, about 3,000 times less than carbon. Easy to write off. But every hemoglobin molecule you own needs 1 iron atom at its core. No iron, no oxygen in your blood. A big bar doesn't mean a big job. Trace describes the dose, never the consequence. So, 3 things. Organic means a carbon skeleton. Not natural, not healthy. The skeleton holds the shape. The functional groups decide the chemistry. And rare never means unimportant. Just ask iron. Get those 3, and Unit 1's chemistry stops being a memory test. Want to build the molecules yourself? The link's below.